In today's video number 39, as part of statistics for economics for class 11, let's learn the measures of dispersion. To learn these measures of dispersion, we need to first recollect what we learned as average or mean. What did this mean to us? Mean represented a set of values in a distribution. Mean is a single value by itself. And mean does not tell us the extent to which the individual values fall away from it. That is, it talks only of, or we can say it is only a representative of the size of the values. But it does not talk of the spread of the values. So we need to understand this mean better with the help of this so-called dispersion. Now dispersion talks of the spread of values. Dispersion, what does it mean? It means distribution. It means scattering of values from the average, or we can call it variation. From the average value, how far the other values are placed or dispersed. Let's understand this better with the help of an example. This example is taken from the NCERT textbook. It says the income, family income of three people, three friends, Ram, Rahim and Maria. Now here Ram talks of four members in the family who earn 12,000, 14,000, 16,000, 18,000 rupees, and it totals up to 60,000. And Rahim's family, there are six members and all of them earn 7,000, 10,000, 14,000, 17,000, 20,000, 22,000 rupees. And in Maria's family, who is a third member in the friends, Maria does not do anything, so she doesn't earn any money, whereas the other four members in the family earn. And they earn respectively 7,000, 8,000, 10,000 and 50,000 rupees. Now here the totals are Ram's family 60,000, Rahim's 90,000 and Maria's 75,000 rupees. That's a total of the values. Now if you calculate the average of the income, we find 60,000 divided by 1, 2, 3, 4, okay, 90,000 divided by 1, 2, 3, 4, 5, 6 and 75,000 divided by 1, 2, 3, 4, 5, okay. That's how we calculate average, isn't it? Now the average of all the three happens to be 15,000 rupees. Now what is the observation that we made? See, though there are 4 members or 5 members or 6 members in the family, the average income in all the three families happens to be 15,000 rupees. Now what is the observation that we make with the help of this data given to us is in Ram's family there is less difference in the values, whereas in Rahim's family there is slightly more difference. One is earning 7,000 and the other is earning 22,000, which is, away from 15,000. Then in Maria's family, there is a lot of variation. One earns 7,000, the other is earning 50,000 rupees, which is way too big number, isn't it? So the difference in these values is different in all the three friends. However, the average income happens to be the same. So this is where dispersion comes to help. So those income inequalities will be better explained by the dispersion. That's what we are going to learn in this video. Dispersion quantifies the extent to which the values vary, or simply called variation. Now this dispersion has got various measures, and they are range, quartile deviation, mean deviation, and standard deviation. This range and quartile deviation measure the extent to which or within which the values lie. The extent within which the values lie. So it talks of the lowest value and the highest value and the values lying within it. Mean deviation and standard deviation measure the extent to which the values differ from the average. From the average, how different are they, is what is learned through mean deviation and standard deviation. Now, the absolute measures show us the values in the same units, whereas the relative measures of these measures of dispersion show us the values in percentage or ratios, otherwise called coefficients. So since they are in the form of a percentage or a ratio, they will not have any units, whereas absolute measures will have the same units as expressed in the data. So since we go one step ahead of the averages, they are called as the averages of the second order. Now, if absolute measures of dispersion are range, quartile deviation, mean deviation, and standard deviation, the relative measures would be coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, and coefficient of variation or standard deviation. Okay, so those are the absolute and relative measures. Let's learn these measures one by one. What is range? Range is the difference between the largest value and the smallest value in a distribution. If you write the formula, range will be represented by the letter R, which is equal to the largest value represented by L minus the smallest value represented by S. Higher range shows higher dispersion, and a lower range or a lower value of range would show lower dispersion. Let's take an example to understand this. Now, range of the values 20, 30, 40, 50 and 200. This example is also from the NCERT textbook only. Now, what type of a series is this? This is an individual series. Now, what is the range of these values? We know by formula range is equal to the largest value minus the smallest value. Now, here what is the largest value? 200. What is the smallest value? 20. So, 200 minus 20 gives us the difference of 180. So, this is the range. Now, for example, to understand range better, when we said that it lies between the higher value and the largest value and the smallest value, if 200 is removed, if you remove this 200, what will happen? The largest value now becomes 50, isn't it? So, what will be the range now? 50 minus 20. So, 30 is the range. What does this show? This shows that range is affected by extreme values. Extreme values. Now, if you remove this 20, then 200 minus 30. So, the value would be only 170. So, the extreme values would definitely affect the value of range. Now, instead of 50, if we write 150, then what will happen? Since all the values lie between this lowest and the highest values, what will happen to the range? Nothing will happen. 200 minus 20 is equal to 180 because the highest value and the lowest value are more important to us than any value that lies between these extreme values. So, R or range is unchanged. Then R cannot be calculated for open-ended frequency distribution. Why? Let us look at the open-ended distribution. Less than 10, 10 to 20, 20 to 30, more than 30. So less than 20 does not give us the lower value or the smallest value, and more than 30 does not give us the largest value. So range cannot be calculated for open-ended frequency distribution. Now that is a limitation for range. Where do we need this range in our daily life? Let's see. The minimum and the maximum temperatures, rainfall, etc. That is weather report. High and low values of shares of a company, that is fluctuations. Prices of items. Quality control. This is where range is most useful to us. Now let's also learn the counterpart of it, that is coefficient of range, the relative value of range. This is given by the formula, the difference between the largest and the smallest values divided by largest value plus the smallest value. Now what did we learn? The relative values are expressed in terms of either percentages or ratios. So if L is equal to 200 and S is equal to 20, then coefficient of range will be given by 200 minus 20 divided by 200 plus 20, which is 180 by 220, and the value is 0.82. Alright. Now let us look into discrete series. For a discrete series, let us take this example of marks and number of students. The marks are given to us 25, 30, 35, 60 and 75, and the respective frequencies. Now what is range by formula? L minus S. What is L here? The largest value is 75 and the smallest value is 25. So 75 minus 25, which is equal to 50. So this is the range. Now what is the coefficient of range? Coefficient of range is the ratio, isn't it? L minus S by L plus S. So L minus S we have already found out, 75 minus 25 divided by 75 plus 25. Now what is this equal to? This is equal to 75 minus 25 is 50 divided by 100, which is equal to 0.50. So that is the coefficient of range for this particular discrete series. Let's also learn the range for continuous series. The size of the items is given and frequency is also given to us. Observe that this is an inclusive series. We have to convert it into exclusive series. What do we do to that? The difference between these two values is 1. 1 divided by 2 is 0.5. So what do? We subtract 0.5 from 1 and add 0.5 to the upper class limit. So what will be the values now here? Exclusive class interval will now become 0.5 to 5.5. Similarly here this will become 5.5 to 10.5, 10.5 to 15.5, 15.5 to 20.5 and 20.5 to 25.5, 25.5 to 30.5. Now range is largest minus smallest values, which is equal to, now the largest value is 30.5. So 30.5 minus the smallest value is 0.5, isn't it? So 0.5. So this will be equal to 30. So range is 30. Now what's the coefficient of range? Very simple now. Is equal to L minus S, we have already calculated, 30 divided by L plus S. L is 30 and S is 0.5. So 30.5 plus 0.5 will give us 31, isn't it? So what is the value of 30 by 30.1? Sorry, 30 by 31. So this will be equal to, so roughly around 0.9. Okay. So if you can find the second, 0.97. So that will be the coefficient of range. We will learn about the next in the series in the next video.